Hello viewers, welcome to our YouTube channel Incredible Maths. In this video, we will solve some problems as in GATE 2022. So the first problem is, this is question number 17. Consider R2 with usual metric A equal to set of all x comma y in R2 such that x square plus y square less than or equal to 1. That means set of all points on and inside the unit circle, and B is set of all points satisfying x minus 2 square plus y square less than or equal to 1. So M is defined as A union B, and N is defined as interior of A union interior of B. So we have to see which is connected and which is not connected. Suppose if we take M, so our set M is set of all x comma y such that belongs to R2 such that x square plus y square less than or equal to 1 and x minus 2 square plus y square is less than or equal to 1. So that means if we take this one, so let us draw this one. So unit circle, draw the line. So unit circle, suppose this is 1 and this is our unit circle, and let us draw the this curve x minus 2 square plus y square is less than or equal to 1. So here the center is 2, 0 and radius is 1. So this point is 1, 0 and this is 2, 0 and radius is 1. So therefore this will intersect some other color. So consider the circle. So therefore this is our M is this one. So if we take any 2 points, so those 2 points can be any point in M and any point in this one A and B. So those 2 points can be connected using the polynomial line. So therefore M is connected. So this one is connected. So now let us see N. So N is interior of A union interior of B. So that means, so the set of all points on the circle will be omitted here. So therefore, there will be a gap. There is no intersecting point. So there will be a gap. So therefore, N is not connected. So N is not connected. So therefore, the answer is C. M is connected and N is not connected. So the next question. The real sequence generated by the iterative scheme xn is equal to xn minus 1 by 2 plus 1 by xn minus 1 comma n greater than or equal to 1. So this is a given sequence. So we have to see to which value this sequence converges. Suppose if this sequence converges, then we have the condition modulus of pi dash of x is less than 1. So we will take this as pi of x. So pi of x is this one. So pi of xn is xn minus 1 by 2 plus 1 by xn minus 1. So therefore pi of x is x by 2 plus 1 by x. So now we will find pi dash of x. Pi dash of x equal to 1 by 2 minus 1 by x square. So the condition is pi dash of x is less than 1. So therefore 1 by 2 minus 1 by x square is less than 1. So this is a condition. So this implies minus 1 less than 1 by 2 minus 1 by x square less than 1. So now we subtract 1 by 2 from this inequality. So we will get minus 1 by 2. So minus 3 by 2 less than minus 1 by x square less than 1 by 2. 1 plus 1 by 2, sorry, 1 minus 1 by 2, it is 1 by 2. So now if we multiply by negative sign, so we get 1 by 2 minus 1 by 2 less than 1 by x square less than 3 by 2. So now if we take reciprocal to this, so we will get so minus 1 by 2 less than 1 by x square. So we get x square is less than minus 2, and so we take reciprocal here. 1 by x square is less than 3 by 2, so we will get x square is greater than 2 by 3. So x square is less than minus 2 by 2 and x square is greater than 2 by 3. So we get x greater than root of 2 by 3. So x greater than root of 2 by 3. So now we will find the convergent value. So the convergent value is find out by using this one. So since xn equal to xn minus 1 by 2 plus 1 by xn minus 1. So we have, suppose if this sequence converges to the value L, so L is equal to L by 2 plus 1 by L. So L is equal to L square plus 1 by 2. So 2L square is equal to L square plus 1. So L square this is 2. So L square is equal to 2. So that means we have L equal to root 2. So therefore this sequence converges to the value root 2. So the condition is x should be greater than root of 2 by 3 and L is equal to root 2. So therefore, so the correct option is option B. Correct option. So converges to this is the value, convergent value. So converges to root 2 and x naught is greater than root of 2 by 3. So now the next problem. So this is based on differential equation. The initial value problem dy by dx equal to cos of xy. X belongs to R, y of 0 equal to y0, where y0 is a real constant. Has unique solution, exactly two solution, infinite many solutions, and no solution. So let us see here. So this is the form dy by dx is equal to f of x comma y. So what is f of x comma y? It is cos of x comma y. So this function is a continuous function, so this will satisfy the Lipschitz condition. So it's a bounded, so it's a Lipschitz condition, satisfies the Lipschitz condition. Therefore, we have unique solution. So the correct answer is unique solution. So f of x comma y satisfies Lipschitz condition. So therefore, this problem has unique solution. So next one. So if the eigenvalues, eigenfunctions correspond to distinct eigenvalues, lambda, the Sturm-Liouville problem, d square y by dx square minus 3 y by dx equal to lambda y, 0 less than x less than lambda, y of 0 equal to y of y is equal to 0, are orthogonal with respect to the weight function w of x. Here we need to find weight function. So here we have formula to find the weight function. So before that, so we will write this in the general form. So general form of this equation will be a2 of x y double dash of x plus a1 of x y dash of x plus a naught of x into y. So this is equal to lambda into y of x. So comparing these two equations from 1 and 2, so we have a2 equal to 1 and a1 equal to minus 3, a0 equal to 0. So the formula to find the weight function is w of x is equal to e power integral a1 of x minus a2 dash of x divided by a2 of x. So this is the formula. So now our a1 of x is 1 minus a2 of x is a1 of x is minus 3, a2 of x is 1, so a2 dash of x is 0 divided by a2 is equal to 1 into dx. So this is equal to e power, so minus 3 dx, so this is equal to e power minus 3x. So the correct option is option A, e power minus 3x.